So in the previous video I set you a few questions relating to the proving trig identities material we'd covered in class. What I'm going to do here is I'm going to work you through the solutions to these and show you how to approach questions of this kind. Here's a quick refresher for you. These are the three questions that I set you. So prove each of these following identities goes from here to here. Now, when you're doing one like this, remember what we said in the video. You can't just assume both sides are equal. You have to take one side of the equation, ignore the other, and transform it into that. You cannot assume that it's true, especially when it's a prove the following question. This is when it's key as well to know all your trig ratios and relationships, because it can bring any element, anything from National 5 right the way up to the higher material we've covered. You need to know them all. Let's have a ping. So the first one was prove sin x plus cos x all squared equals 1 plus sin 2x. So again, we take this side here and we say, right, I have to turn it into the right hand side. I cannot assume the right hand side is right, I have to show the right hand side is right. Now one like this, the first thing we have to do is take sin x plus cos x in the brackets squared and multiply the bracket out using FOIL like we would for quadratics back in National 5. Doing that, we get sin squared x plus 2 sin x cos x plus cos squared x. Now, we can group bits together. So if we group the squares together, we've got sin squared x plus cos squared x. We've then also got the plus 2 sin x cos x. And this is where your trig ratios and identities start to come into play. Sin squared plus cos squared, we'll need to remember, equals 1. That's something we got taught in National 5. And the 2 sin x cos x, well, that's one of the double angle formula we've covered. 2 sin x cos x, that's the equivalent of sin 2x. So what that means is I've essentially got this bit here, which I know is 1, plus this bit here, which is sin 2x. And when you look at that, that equals the right hand side. So what we've done here is we've proven this. We have to tell them that. We then say, therefore, sin x plus cos x all squared equals 1 plus sin 2x. Now I can tell them it's right. Now I've shown this is the case. We have to get to that point. Next question was this, 1 plus cos 2x over sin 2x equals 1 over tan x. Again, same steps. Take this side and make it this one. Don't assume it's true. Don't work with both sides together. So 1 plus cos 2x over sin 2x. This is when we have to start using our double angle formula. Now cos 2x has got three different variations. Cos squared minus sin squared, 2 cos squared minus 1, or 1 minus 2 sin squared. The one that we really want to use is the 2 cos squared x minus 1. Now if we use that, we're going to have a 1 and then a minus 1, so they'll cancel. So we might get something a little simpler to work with on the top. So let's use that one. So I get 1 plus 2 cos squared x minus 1 on the top, and then sin 2x, we've only got the 1 for that, 2 sin x cos x. Now the top, I've got the 1 and the minus 1, that cancels, so I'm left with 2 cos squared x over 2 sin x cos x. Now this is the point where simplification comes into play. It's a fraction top divided by a bottom. I can cancel at the 2's. I can also cancel at the cos there and one of the causes from the power there. And that then leaves me with cos x over sin x. Now this can be rewritten as 1 over sin x over cos x. And the reason I want to do that is I know sin over cos is tan. So that then equals 1 over tan x, which is the right hand side, which is exactly what we were after proving. So I can then say therefore 1 plus cos 2x over sin 2x equals 1 over tan x. It's definitely true now. I've shown it. That's the identity proven. Final one I had to do was cos 3a equals 4 cos cubed a minus 3 cos a. Now one like that, you're looking at the cos 3 and thinking, what the heck can I do with that? Well, 3a, we can write that as a plus 2a. And if we've got that, we can then use our wave expansion on it. So what I can then say is cos 3a equals cos of a plus 2a, and then expand it using that. And I'd end up with cos a cos 2a minus sine a sine 2a. Now, this is where the fun really begins, because now I'm looking on how do I go from this to something we just caused in it and a cubed. Well, cos 2a and sine 2a are a double angle formula. We want to use them and manipulate them. Now, we've said before about which version we use. This one I'm going to stick with the cos squared minus 1, the 2 cos squared minus 1, because I want to get to a cos cubed. That will help me get that power. So I'd have cos a bracket 2 cos squared a minus 1, take away sine a, and I can use the sine 2a version for this, times 2 sine a cos a. So now I've got that, I can start to expand it. So I can multiply this bracket out, and I get 2 cos cubed a minus cos a, and then simplify this bit, and I get minus 2 sine squared a cos a. Now, I'm looking at this thing and right, I've got something, I've still got a sine in there, but I want rid of sine because it's purely in terms of cos. Well, think back and remember that sine squared plus cos squared is equal to 1. I can rejig that and write it as sine squared equals 1 minus cos squared. And if I was to use that version in here instead of sine squared, I would get rid of the sines and I would have something purely in terms of cos. So let's have a go at that. So I'd have 2 cos cubed a minus cos a, take away 2, open bracket, 1 minus cos squared a times the cos a there. So now I've got nothing but causes in here and a couple of numbers. I can multiply this out and start simplifying it. Here's hoping we get where we want to get. So I've then got 2 cos cubed a minus cos a, take away, well, multiplying this out, I get take away 2 cos a, and I get minus times a minus, so I get plus, and I end up with plus 2 cos cubed a. We now group every part together, so the 2 cubes go together, and I get 4 cos cubed a, so then minus cos a minus 2a, take away 3 cos a. And lo and behold, that is the right hand side. That is exactly what we were after. So what I can then say is therefore cos 3a equals 4 cos cubed a minus 3 cos a. Exactly what we were after proving and exactly what we were after getting out of it. Remember, that's the key thing. You can never assume they're right until you've proven they're right. So take the left side, ignore the right side, and manipulate it to get to that side. Hope that went well for you, and I will see you in class.